I'll now talk about solving equations. And when solving an equation, what we're trying to do is figure out what value of the variable will make both sides of the equation the same. And there are two real rules of equality. You can add and subtract the same number from both sides, or you can multiply or divide by the same non-zero number on both sides. And I'm going to start with the most basic type of equation we have in algebra, which is a linear equation. A linear equation is anything that can be written in this form, ax plus b equal to 0, where a and b are real numbers and x is your variable. They will not always look exactly like this, but we could rewrite the equation to get it in this form. Here are three examples of linear equations. 3x plus 7 equal to -2, 4x equal to 2/3 x plus 1, and x plus 7 equal to x divided by 4. The main thing is all of the x's are not raised to any exponents, they're not on the bottom of a fraction or anything strange like that. Conversely, let's look at a few non-examples. Here are three examples of things that are not linear. The first one, x squared plus 7x equal to 2, is not linear since it has an x squared term. The second one, square root of x plus 5x equal to 12, is not linear since the x is inside of a square root. And the third one, 2 over x minus 3x equal to 4, is not linear since x is on the bottom of a fraction. So now let's look at solving some of these. My first example, 2x minus 3 equal to -25. The first goal we should have is to get all of the variable on one side and all of the constants on the other. So on the left has both variable and constants, so I'm going to add 3 to both sides so I can move that constant to the other side. The left then just becomes 2x, and the right, -25 minus 3 is -22. I then want to get rid of this 2, so I'm going to divide both sides by 2 to get x equal to -11. And we can always double check this. 2 times -11 minus 3, if I stick it back into the original equation, that would be -22 minus 3, which is -25, which is exactly what it should have been. My next one, 3x plus 5 equal to x minus 27. The first step is to get all the variables on one side. In order to do that, I'm going to subtract x from both sides. 3x minus x is 2x plus 5. On the right, those cancel and go to 0, so it's equal to -27. I then want to get the constants together, so I'm going to subtract 5 because I want them on the other side of the variable. On the left, I have 2x, and on the right, -32. We can then divide both sides by 2, and I get x equal to -16. And once again, we can double check. The left side of this said 3 times x plus 5. So if we work that out, 3 times -16 plus 5 gives us -43. On the right hand side I have x minus 27, so -16 minus 27, which is also -43. So both sides matched, so our answer is correct. My next one, -x plus 10 equal to 2 times x plus 5. Sorry, not equal to 31, plus 31. So the first step here before I start getting my variables together is to try to simplify. Distributing the negative sign on the left gives me -x plus 10, or -x minus 10. On the right I have 2x plus 10 when I distribute, plus 31. So -x minus 10 equal to 2x plus 41. I want to get my variables on the same side, so I'm going to start by adding x. I could also subtract 2x from both sides, but I want to avoid having negatives. So that's -10 equal to 3x plus 41. I then subtract by 41 to get my constants on the same side. That gives me -51 is equal to 3x. I then just need to divide both sides by 3. and I get negative 17 is equal to x. And once again, we can check both sides by sticking this into both sides of the equation and make sure that we got it correct. My next one has some fractions in it, but they're not that bad. X over 6 plus 2/3 equal to 3x over 4. And there is a trick to dealing with fractions a little bit easier. The first step is to find the least common denominator. Here it would be 12, since 6 times 2 is 12, 3 times 4 is 12, and 4 times 3 is 12. So I'm going to multiply everything by 12. So 12 divided by 6 would be 2. 12 divided by 3 would be 4 times the 2 that's already there. 12 divided by 4 would be 3 times the 3x that's already there. And now I can see that this is much simpler. I'm going to subtract 2x to get all the variables together. That gives me 8 is equal to 7x. And then I can divide both sides by 7 to get 8 over 7 is equal to x. And once again, we can still stick this back in and double check that we did everything correctly. Expanding on our last example, let's look at rational expressions and rational equations. In my last example, I wanted to multiply by the least common denominator. And here I'm going to do the same thing. There's an x plus 1 on the bottom and an x minus 2. Running out of room here. When I multiply the first thing by x plus 1, x minus 2, you'll notice that x plus 1's cancel, and I'm just left with an x minus 2. For the second one, the x minus 2's cancel, and I'm just left with an x plus 1. And here, they'll actually both cancel, and I'm just left with x plus 3. So on the left, I have 2x minus 1. On the right, x plus 3. Subtracting x from both sides gives me x minus 1 equal to 3. I can add 1 to both sides and get x equal to 4. However, it's now really important to double check this answer because it's possible that we got something that's not correct. Here, if I stick it back into the original equation, I would have 1 over 4 plus 1 plus 1 over 4 minus 2 is equal to 4 plus 3 over 4 plus 1 times 4 minus 2, or 5 times 2. And you can double check, but this is actually correct. Anytime we're dealing with rational expressions, it is essential that we double check our answers. Let's look at one more. Once again, I want to multiply by the common denominator, which is x minus 4. My first term is just a 2 times x minus 4. My second one, 5 over x minus 4 times x minus 4. The x minus 4's will cancel, and I'm just left with 5. And with my last term, the x minus 4's cancel, and I'm just left with x plus 1. That gives me 2x minus 8 plus 5 equal to x plus 1. Or 2x minus 3 equal to x plus 1. I can subtract x from both sides. That gives me x minus 3 is equal to 1. I then add 3 to both sides to get x equal to 4. And like I said before, it is essential that we double check these answers. So when I stick this back in, I have 2 plus 5 over 4 minus 4. And now we can see the issue. I can't divide by 0. So this problem actually has no solution. And this right here is why it's important to double check. One of our rules for equality said that we can multiply or divide by the same number, but we can't multiply or divide by a 0. And that's essentially what I did in my first step here, is I tried to multiply both sides by 0, which isn't allowed. And so we get this error of division by 0. So it is really important to check anytime we have x's on the bottom of a fraction.